Hi, here's a short video to show the correct answers for homework 5. So number 1, you solve for L. So we start with the equation 18.1, V induced equals the inductance times the change in the current divided by the change over time. If we rearrange that and solve for L, we get the voltage induced divided by the change in current divided by change in time. If we do the math on that, it ends up being 300 millihenries or 0.3 henries. Then the next one is the voltage induced equals the henries, the inductance times the change in the current over the change in the time. So it's 100 millihenries times 25 milliamps divided by 40 microseconds, and that comes out to 6.25 volts. All right, and then number 3, same thing. Now we're going to solve for L again, and that comes out to 10 millihenries. Number 4 is 8 henries times 500 milliamps minus 100 milliamps. So it gives us the start and stop, so the change is the subtraction of the two, divided by 5 milliseconds, so that comes out to 640 volts. Number 5 is, again, we're going to solve for L, and that one comes out to 6.25 millihenries. Then number 6 is the energy in inductors measured in joules. 25% of all inductor faults are from opens, and then mutual induction occurs when the energy from one coil is transferred to the other, or coupled to another. Right, and then number 9 is using equation 18.3, where M equals K times the square root of L1 times L2, so that's 0.3, times the square root of 50 millihenries times 150 millihenries, and that comes out to 26 millihenries. All right, number 10 is M equals K times the square root of L1 times L2, 0.5 times 1 times 3, and you come up with 866.025 millihenries. And then number 11, we're going to solve for K. So the equation is M equals K times the square root of L1, L2, so K equals M divided by the square root of L1 times L2, and that comes up to 0.8. And then 12, equation 18.4, series induction is just added together, so it's 400 microhenries plus 250 millihenries, which is 250.4 millihenries. And then in parallel, the total inductance equals 1 over the reciprocal of 1 over L1 plus 1 over L2 plus 1 over L3. And these are all 33 millihenries, so it's basically 1/3 of that, right? So that's 11 millihenries. Then equation 18.5 says the LT equals L1 plus L2 plus 2LM. And to get the LM, you have to take find K, so M equals K times the square root of L1, L2, so that's 0.8 times 8, because 8 times 8, the square root of that is 8, and that comes out 6.4. Then 8 plus 8 plus 6, 2 times 6.4, you end up with 28.8 henries. Right, and then number 15 says 2 coils are connected in series with M equals 15 microhenries, series opposing. So now instead of LT equals L1 plus L2 minus 2LM. So again, we're going to find K, and then once we have K, we can find M, and then so then we're at 50 microhenries plus 50 microhenries minus 2LM, so 2 times 15 is 30, and that comes out to 70 microhenries. And then number 16 says, for this problem, calculate LT if M is series 18, so now you're just going to take 2 times 15 and add it, so 50 plus 50 plus 30 is 130. And then finally 17 is determining the energy, and equation 18.7 says E equals 1/2 the inductance times the current squared, so 1/2 times 100 millihenries times 100 milliamps squared, you end up with 500 microjoules. And then determine the energy stored in an inductor when L equals 50 microhenries and the current is 20 milliamps. So again, it's 1/2 times 50 microhenries times 20 milliamps squared, and that comes out to 10 times 10 to the negative 9 joules, or 10 nanojoules. And then finally, 18 says an inductor storing 0.005 joules. If the current is 100 milliamps, determine the inductance. So here we're going to solve for L. So if E equals 1/2 Li squared, take everything times 2 and then divide by I squared, and that comes out to 1 Henry. And then finally, determine the energy stored in an inductor when L equals 2.5 H and the current is 250 milliamps. So 1/2 times 2.5 times 250 milliamps squared, you end up with 78.125 times 10 to the negative third joules, or 78.125 millijoules. All right, so that is homework 5, which was last week's homework. All right, take care. Bye.